Welcome back from Easter break. Let's look at our second problem from the t-test sample problems that I gave you. All right, so this one says, and I have some information written on the board, the average local cell phone call length was reported to be 2.27 minutes. A random sample of 20 phone calls showed an average of 2.98 minutes with a standard deviation of 0.98 minutes. At a 0.05 significant level, can it be concluded that the population average is not 2.27 minutes? All right, so the question is always the alternate hypothesis, and it says at a 0.05 significance level, can it be concluded that the population average is not? They didn't say greater, they didn't say less, they just said is not. So for us, that is not equals. So just keep that in mind. That's not equals when it's not. They didn't say greater, they didn't say less, they just said it isn't. So that's going to be a two-tailed test. So when we get to our graph over here, or our sketch, we're going to cut up both sides. So our alpha that they said was 0.05 will now be cut in half. So it's 2.5% on the left, so that's a half of alpha on the left, and 2.5% of the distribution on the right. And if our sample falls in either one of those half alphas, because total it's one full alpha, right? If it falls into either one of those, we're going to reject. If it falls in the middle, we're not going to reject. It's close enough, we're going to say, nope, not enough information to say it's different. All right, remember, if it falls outside of these in alpha, we're going to say, go ahead and reject. So here's some of our important information. Mu, our population mean, is 2.27. All right, so that was, let's see, let's go to step one. Mu is the average phone length. You could put in minutes, but I don't have enough space, and that's 2.27. That exact same number has to be down here, 2.27. Those two numbers must always match. So here's our null hypothesis, mu equals 2.27. Null hypothesis will always have the equal sign. Then the alternate hypothesis, that's our claim, that's our question, was it's not 2.27. So I just put a not equal sign. Our assumptions, x bar is from a simple random sample. The second assumption is that n is large. It's not, but they gave us two. If you look in your book, either n is large, or we can assume, which we're going to do here, that the population distribution is approximate normal. So the population distribution is normal. Yeah, we could probably think that when it comes to cell phone calls. Most of them are right in the middle. There are some that are very short, there are some that are long. It probably looks like this, okay? And our third one is that sigma is unknown. And that's why we use a t-test. When we know sigma, we use a z-test. When we don't know sigma, we use a t-test. So we're going to use a t-test. Step 3, our critical value. This is where we use our chart. So the chart that we have that I gave you in the last handout or in the back of your book, we're going to find this critical value. So this is based on a degree of freedom of 20. So remember, degree of freedom is n minus 1. Silly name, degree of freedom. Just live with it, okay? So it's 19. So you go to the very left-hand column, look for degree of freedom 19, and then scroll over to the column that says two-tailed 0.05. All right, so we're going to go 19 over, or go down to 19, and then we go to two-tailed 0.05, and we find the number 2.093. But wait a second, look over here. We have two places for critical value. So one is negative. That's going to be negative. So let me put a plus or minus in front of this. One is negative 2.093, negative 2.093, and the other is positive 2.093. All right, let's go ahead and do our calculation. This calculation is based on this formula. All formulas are given on test. Don't worry about formulas. So the t-value, or the t-test statistic, is equal to x bar minus the hypothesized mu, that's this number up here, divided by s over radical n. It's kind of like a z-score. It's a t-score. So I plug my numbers in, 2.98 minus 2.27 divided by 0.98 over radical 20. I would do these two first, 0.98 divided by radical 20. I would do that first to get a number. I would subtract those two, get a number. Get a number over a number, okay? A fraction. Divide, you're going to get positive 3.241. Well, where does that lie? Let's see. If the middle's always 0, the middle is always 0, positive 2.093. So boy, that must be outside. That's moving over here. We're going to estimate that it's right there. That's my t-test statistic. It ended up in alpha. So what does that tell us? It's way out here in our half alpha, in our alpha. That tells us we are going to reject, right? Because t is inside of alpha, okay? So our conclusion, which is, wait, this is step 4. Step 5 is we're going to reject HO. That's the null hypothesis. And then I write these words the same every time, if you haven't noticed. There is evidence, right? There is significant evidence. There is significant evidence that the mean phone call length is not 2.27. I wasn't trying to prove that it's greater. I wasn't trying to prove that it was less. I was just trying to prove that it's not. So that's why I write this, that it's not, okay? I don't want to say that it's greater, okay? That wasn't what we were trying to prove. We were trying to prove up here in our alternate hypothesis that it is not. So this must reflect the alternate hypothesis, okay? We have evidence that it's not 2.27, okay? Our next big topic you're going to love. It's totally different from any of this. It's a totally different kind of statistics. It's called correlation and regression. So that'll be our next video.